In this lesson, I'll show you how to solve equations involving two or more absolute expressions. Now, we have looked at how to solve absolute equations, namely those that are linear, and these are linear, except when you have two absolutes in an expression, two separate ones, it gets a little more difficult. In fact, in the past, let's start with question A, when we've had one absolute and let's say an integer on the other side, we simply solve it as if it's a linear equation, and then we solve it again with this being negative. That's not the case here. In fact, you have four different possibilities as to what your answer can be. One of the possibilities is that the expression x minus 1 gives you a positive output, and the expression x plus 3 gives you a positive output. That's one possibility. So you will solve this as if these are expressions that are positive for x. Another possibility is that these two are negative. That's two possibilities. The third possibility is that this is negative and this is positive, and the fourth possibility, this is negative and that's positive. So you have to solve this four separate times because of the four different possibilities. In case you're confused, here's what I mean. So I'll rewrite this and I'll replace these absolute values with parentheses, brackets, and I'll solve for x. So I have 1 over 4 bracket x minus 1 plus 2 over 3 x plus 3 in parentheses is equal to 5. Notice that I've replaced both of these absolutes with brackets, and this represents possibility number 1, where these two are both positive. Now if we solve this, I'll expand the left side, where I have 1 over 4x minus 1 over 4 plus 2 over 3x, and 2 over 3 times 3 is equal to 2, and that's equal to 5. Next, I'll bring this positive 2 and negative quarter over to the right side, where I have 5 minus 2 plus a quarter. And on the left side, I have 1 over 4x plus 2 over 3x. I'll use my calculator. 1 over 4 plus 2 over 3 gives me 11 over 12. And on the right side, we have 5 minus 2, that's 3 plus a quarter, 3.25. 3.25. 11 over 12x. And I'll divide both sides by 11 over 12. And if I do that, I should end up with 3.25 divided by what was just on my screen, 39 over 11. X is equal to 39 over 11 is one possible solution. That's when both of these are positive. Let's see what happens when both of them are negative. So I've shifted the work that I just did on the side, and I'll redo this, and this time I'll make this negative and that negative. So I have 1 over 4 times negative 1 bracket x minus 1. That's what I mean by this being negative. So I have 1 over 4 times negative 1. I'll put a dot right there. Plus 2 over 3 times negative 1 x plus 3 is equal to 5. Let's go ahead and do this. We have negative 1 over 4x, and these two multiply to negative 1 gives us a positive 1 over 4. And I'm just following along what I did before, except I'm keeping in mind that they're different signs. So this is positive 2 over 3x. This should be negative 2 over 3x. Minus 2 is equal to 5. I'll bring this term and this term over. 5 plus 2 minus a quarter. And I'll combine negative 1 over 4 with negative 2 over 3. That gives me negative 11 over 12. And over here, I have 7 plus negative a quarter. And that's 27 over 4. I'll divide both sides by negative 11 over 12, where I end up with a brand new x value, negative 81 over 11. That is another possible answer for x. Another possibility is if this is positive and that's negative. So we'll have to solve this a third time. So I brought my previous solution underneath, and this time I'll make this negative. 1 over 4 times negative 1 x minus 1 in brackets plus 2 over 3 x plus 3 is equal to 5. Here we end up with negative 1 over 4x plus 1 over 4 plus 2 over 3x plus 2 is equal to 5. If I solve for x, I should end up with 33 over 5. Now I didn't show my work, but because it's the same thing over and over again, you should be able to come up with these answers. My last possibility is if this is negative and that's positive. So here we go again. 1 over 4 bracket x minus 1, that doesn't change, plus 2 over 3 times negative 1 bracket x plus 3 is equal to 5. Let's expand. Now if we solve this correctly, we should have an x value that is equal to negative 87 over 5. So how do we decide which of these possibilities, which of these solutions, which I'm highlighting, make this equation equal on the left and on the right side? Well, what you have to do is take every possible solution, substitute it into the x, and see if the left side in our case is equal to 5. Now, without having to do that, I've done it already for you, and I found out that the only things that make the equation equal is this and that. Therefore, for question A, the solution is 39 over 11 and negative 81 over 11. And just to prove, I will show you one of them, and that way you know what I'm referring to. So I'll take negative 81 over 11, place it into there. Negative 81 over 11 minus 1 gives us negative 92 over 11. Now, because that's an absolute, it becomes positive. So I'm going to multiply that by negative 1, and I'll multiply that by a quarter. So this term is equal to 23 over 11. I'm going to do the same thing over here. I'm just going to write that down for reference so I don't forget. Once again, I'll take negative 81 over 11 plus 3. This has to be positive, so I'll multiply by negative 1 because it's an absolute, times 2 over 3, and I get 32 over 11. So if I add 32 over 11 plus 23 over 11, I end up with 5. Now I can assure you that if you place this into x here and x here, you will not get 5. Neither will you get 5 if you place 33 over 11 into here. Now, if you'd like to see the answer to question B, make sure that you watch part 2 of this series, which I'll be doing next.